Hello everyone, and welcome to OneClass. My name is FeOH3, and I'm an Honors Bachelor of Science graduate, currently working towards medical school. Today we'll be going over some commonly asked chemistry questions at both the high school and college levels, and I will be doing my best to answer them. If you need some extra homework help or just some tutoring, please check out the links in the description below. With that being said, let's kick it off for today with question number 1. Which is, what is the name of each compound? And let me just quickly switch my screen over. Alright, hopefully you can see me. And yes, we're starting with what is the name of each compound? So the first one we have Na2O. And then we have FeOH3. Okay? Both very interesting compounds, but let's see how we can get more information out of them. So the first thing I notice here is if we look at them, sodium and oxygen refer to our periodic table. Okay? And sodium is considered a metal. Because on the metal side, if I hover over the metals, sodium should light up. Perfect. And oxygen is considered a non-metal. As I highlighted here, oxygen is considered a non-metal. And even look at the Fe. Actually, we're not going to look at that one because OH3 is considered hydroxide. Hydroxide, okay, because it's OH3, would also be, if you hover over the non-metals, we have oxygen, which is a non-metal. But we also have hydrogen here when it's highlighted, indicating that it's also a non-metal. Okay, the reason why I point this out is because we need to understand, in order to name it, that these are ionic compounds. Okay, and now because we know that, we can approach it with certain naming rules. Alright, so Na, if we refer back to the table, is sodium. So we would have sodium, and then we'd follow that by, what would this be? Oxygen. Sodium, oxygen. Okay? And now, we're not done yet, but at least we have this. What we need to do now is abide by the rules when it comes to the, I guess, suffix of the oxygen. We need to change that. Drop the YGEN, and it'll be IDE. So for the first compound, we just have it named sodium oxide, okay? We'd actually have to do nothing more because it's actually been balanced out. Luckily, sodium is not a transition metal, which is what we're about to get into with iron. But because we know that sodium is just going to be Na plus and oxygen is just O2 minus, we need two sodiums to account and balance the two charge from the oxygen. Now for this, hydroxide actually is OH minus, only one minus. So for them to be 3 hydroxides here, for the iron, it needs to be Fe3 plus. Why is this relevant for iron? Because if you look here, iron is one of the transition metals. It has different states of oxidation, or at least it has different cations that it can have, so it's whether it's iron 2 or iron 3. So for now, what I'm going to put is iron 3. Okay? Whoops, sorry. I'm just going to put iron hydroxide. Okay? We're going to start here because okay, it is a transition metal. We need to now actually specify. Unlike the sodium hydroxide, we need to specify what type of cation we're dealing with iron. So as you can see, it has 3 electrons to give away. So we'd call this iron parentheses 3 hydroxide. That would be how you name this, because for the iron you have to account for the fact that it's a transition metal. All of this though we solve based on the fact that ionic compounds need certain ways to address it. Just gonna make sure everything's plugged in, okay? And exactly, ionic compounds need certain ways to address it, which is why we did it as sodium hydroxide. Now, and sodium oxide and iron 3 hydroxide. So let's see how our colleague did it. Second, they have sodium oxide, perfect, and FeOH3, we have to specify iron 3 hydroxide. So that being said, this is correct. And we move on now to the next question here.